can remember what you have learned during previous semester, from this previous semester, about how to calculate second moment of area. Okay, that is first principle approach, right? IYY, IZZ. Yep. Okay. Remember that you need to, this is rectangular, two rectangular combined. So you can divide the area, first rectangular and second rectangular, and then you can calculate the centroid to the reference, to the datum. Remember, AY divided by summation of Y to determine the centroid, and then you need to use parallel theorem to calculate the second moment of area, where I is equal to whatever, BH power of 3 divided by 12 plus AD power of 2. Okay? Okay. And then we need to classify, okay? So to classify this section, first, okay, since we already have the proposed size, so we just access the this particular size lah. Okay, thickness is 15, so obviously it is less than 40. Let's say the grade S275. Oh no, the grade is S355. Okay, now I want to ask, to determine FY, which table that I need to refer to? Akmal. 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 Akmal.
Ya,
Kat mana table apa saya nak refer kalau saya nak cari FY? Nak cari FY ni, nak refer table berapa dalam BS, dalam Eurocode 3? Saya risaulah sebenarnya dengan korang ni. Benda simple korang tak boleh jawab. Saya sangat risau. Saya nak bagi tahu sem lepas kita ada 200 pelajar ambil still. You tahu tak berapa yang fail? Fail. Nak dekat 60 orang. Fail Yang D jangan cakap lah, berlambak je. Saya bukan nak takutkan, tapi saya nak you ambil serius lah. Kita dah buat dah. Berapa banyak kali kita buat FY. Tak tahu lagi ke mana fikiran awak. Kenapa sampai macam tu? Awak bukan budak sekolah. Saya nak kena tanya. Ni saya punya inisiatif. Saya tanya satu-satu. Kalau saya bukan concern, saya lantak you lah, you tak faham. Saya akan terus je dengan saya punya contoh. Saya takkan tanya. Azim. Muhammad Azim. Akmal, cari Akmal. Nanti kalau dah ni awak bagi tahu.
Table 3.1 isi 34141.
Dia kena hafal dah. Semua dah kena hafal. FY kat mana? Section classification table berapa? 2 tu. Memang kita sentiasa repeat. We always repeat. To determine FY, to determine section classification, you need to be familiar with the number of the table. Okay, so table 3.1. So from table 3.1, okay, thickness is less than 40. Still grade S355, definitely FY will be 355. Okay, mana table 3.1? Okay, ni. S355. Thickness 40, less than 40. So FY 355, 355. So FY is 355. So epsilon, okay. Table berapa untuk section classification? Which table that we will need to use for section classification? Shafi, Syafi.
Yes, betul.
Table berapa?
Sekejap tengah cari.
Baru tadi sebut Syafi. Bagus. Baru sangat.
Yang kalau epsilon tengah cari, kalau yang tadi tu 3.1.
Ya, masa saya terangkan tadi, saya kata you kena ingat 2 table. Saya dah bagi tahu number dia.
Sekejap. Saya baru nak cek muka surat dia tadi.
Tebal tu you nak selak. Memang tebal. That's why saya suruh hafal. Naiman dah jawab tadi. Nick Mazlina. Bantu Syafi. Nick Mazlina. Nick, kalau tak boleh pakai tu, pergi dekat chat. Okay.
Sorry Doktor, line saya slow tak?
Okay. Type dia, tak apa. Berapa?
5.2 Doktor, 5.2 Doktor.
5.2. Syafi, 5.2. Jumpa tak?
Jumpa doktor.
Syafi? 31 5.2 akan sentiasa guna except untuk tension member. Bending member kena, compression member lagi lah kena. Okay. So table 5.2. Okay. We are using angles. Okay. We are using angles. So, okay, this is not related. This one also not related. Okay. Only sheet 3 that related to angle section. So what we need to do is set here. Okay, we need to access class 3 only. Means that if the result do not fulfill class 3, automatically it will be classified as class 4. And it's not significant for us to determine whether it is in class 1 or class 2. Just fulfill class 3. That's all. Okay. Unlike the other structure. See, the other structure, you can access class 1, class 2, class 3. Okay. So, H over T and also B plus H divided by 2T. That's all. Okay. So, as in this solution, H over T, B plus H divided by 2T. Okay, H is the height, 150. The thickness is 15. Directly you can determine the value. Okay, this one equal to 10, which is less than 15. Okay, 15 epsilon. Okay. Okay, before that epsilon 0.89 0.81. Okay, so the value of 15 times epsilon is equal to 12.2, still bigger than 10. So, okay, the first assessment pass. What about the second? B plus H. B also 150. H is 150. 2T, T is 15. Okay, also 10. Okay, then we need to compare with 11.5 epsilon. 11.5 epsilon is 9.3. Obviously, 10 bigger than 11.5 epsilon. It is bigger, so it is not fulfill class 3. So it will be automatically in class 4 section. In class 4 section. So, in order to design this member subjected to compressive force, right? How to design compressive force member? Okay, refer to Eurocode. I said all okay. For design part, you will refer to clause 6.2, 6.3. Okay, 6.2 and 6.3. Okay, 6.2 first. Okay, 6.2. I don't like we remember the exact formula because there's a lot of formula. So I want to teach you how to use this Eurocode. Okay, for 6.2. Okay, this one is for ultimate limit state. Resistance of cross section. There are two types of resistance that you need to assess. First, the cross section. Second is the buckling. 6.2, 6.3. So for 6.2, resistance of cross section, the element that we try to solve now is compression member, right? Compression member. So look at the design for compression member. Okay, this one is for tension. Okay, yeah, this one is for compression. Compression, but we have another thing. MCRD. That one is also compression, but M stand for bending member. What we try to solve is the member that's subjected to compressive force. The axial compressive force. Betul? Axial kan? Bukan bending kan? Axial dikenakan daya paksi dalam bentuk compression. So N, I said N is N axial force C compression. So we need to refer to this clause 6.2.4. So what we need to determine the NCRD. Okay, now we know that we need to solve NCRD. This one is for cross section resistance. The first resistance we need to assess. NCRD, remember this one. This element fall into class 4 section. So inilah. Okay, this one. Yeah. A effective. So where to determine FY? 355. Remember Newton per mm squared. Remember table 3.1. It's 1.0. Yeah. A effective. Okay. For A effective, if you refer to Blue Book, you can look for A effective. A effective. What is the explanation about the A effective? Okay, see? For A effective section property subject to compression. See, you need to read all these things. You're using equal angle. So this is the formula. 1 minus rho H, and then you need to determine the rho. Okay. But okay, since I said that we will refer to Blue Book. Okay, the Blue Book is very complete reference. A effective, you can directly take from the table. Okay, just look for A effective for of angle. Angle. Mana angle? This is I section. Okay, angle. This is unequal angle. Using equal angle, size 15. Okay, 43. But this is equal. This is gross area. Equal single angle. We are using double angle, so we need to multiply by 2. But as you can see here, gross area, okay, is equal to the effective area. Gross area is equal to the effective area. This one we refer to as 275. Our case is 355. So plus 4. Plus 4. Okay. we find that the section is class 4, which is true, which is correct, okay, according to this table. Effective area, as what been explained in this statement. It said that the section is a class 4 and it is therefore not fully effective in uniform compression. So you need to determine the effective area. But if you calculate, they said such a calculation leads to a fully effective area, as what been proven as from the Blue Book. It's proven, kita dah prove kan, memang sama pun. Okay, okay, this is the evidence. Okay, lead to the value of the gross area. So that's why A effective here is equal to 86. Remember, double, single 43, right? So double 86. And then, okay, A is 86 centimeter squared. So then you need to calculate. Okay, this is not correct. It should be A effective. But since A effective is equal to A, so this one is S. So 3,000 something. That is the resistance of cross section. I said that you need to evaluate the cross section resistance. That is the first. Second, buckling. Okay. Why we need to evaluate these two resistance? Because in our case, we rarely deal with short element. You will frequently encounter with element that could be intermediate length, having intermediate length, or slender. Okay? For intermediate and slender, I said, apart from the cross-section capacity, buckling is prone for such a member, slender and intermediate. So you need to evaluate the capacity, the buckling capacity. Okay, so for buckling capacity, you will refer to clause 6.3. That is for buckling. Okay, refer. Okay, see 6.2. You have bending and shear. You have bending and axial force. Okay, for the case where the weight is quite significant. I mean, maybe it's heavy because of very large. It will bend. Okay. And then for truss member, you have axial force and ED. So you need to consider this one. You need to consider cross-section resistance. You need to consider buckling. You also need to consider bending and axial force. Banyak tau. There's a lot. Okay. But first you need to know what type of force that the structure that the structure have, that the structure will support. Okay. Okay. 6.3. Okay, 6.3. Okay, 6.3 is about buckling resistance. Okay. So I said, okay, remember that the element that we try to solve here is a truss element. Truss element and for axial force, subjected to axial force. So buckling should be N lah, not M. M is for bending member, and for member that being subjected to axial force. So this is the formula that we will check. We will solve. Okay, this is the clause that we will solve. NBRD. Okay, so for NBRD, okay, said for member with non-symmetric. In our case, it is symmetric, right? Symmetric tak? Huh? Symmetric lah. Should be symmetric because we are using double angle. For this axis, see the mirror. That is what you're being taught, right? To know symmetric or non-symmetric. Bila kita lipat dia jumpa kan? Pemahaman yang mudah. Mirror, the image. Exactly. Okay. This is just symmetric at one axis. But for this axis, no. Okay. Bukan. But still symmetry for one axis. Okay, so this is not our concern. Okay, so it said for class non-symmetric class 4 blah blah blah, you need to refer to 6.2 should be carried out 634, 633. Okay, so you need to read one by one. Okay, since it doesn't concern us, we move on to another paragraph. Okay. Okay, the design buckling resistance of compression member should be taken as this one. Ours is, okay, our case is class 4. So we will solve A. We have the value of A effective. We also have Fy. Chi. Okay, chi. For chi, okay, I already teach you last week about how to determine chi. Okay, so now I can speed up a bit. Okay. Okay. The other thing that you need to be careful is that, okay, how many axes? Okay, in this case, since this is a double angle, since this is double angle, the buckling will be about Y, Z and Y axis only. Okay, but for single angle, okay, remember it can buckle VV, UU, YY, ZZ. We have 4 axes. Okay. Okay. So that's why in this case, we will only assess buckling about 2 axes, Y and Z. Okay. Buckling resistance in plane of the truss. Okay, for in plane, you can take as 0.9 L. L is given, okay, 5,464, 0.9, so this is the value. Okay, NBRD, this is Z, okay, Y, okay. Okay, ini yang hari tu, okay. This is what explained in the module. Ini. This one. Example 5.8. Okay, example 5.8. This is example 5.8. This is the detail, including the figures. Okay. 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 Oh, I already explained this one lah. I already explained. Okay. Why? Okay. I need to determine, okay, what type of the arrangement. Because for the in-plane truss and for the in-plane buckling, it refers to Z axis. So to have buckling at Z axis in plane dalam SATA, the arrangement should be like this, not this one, like this. So it will buckle. It will buckle up and down in plane of the truss. Contohnya, for example, this is your truss. I hope that you can see my video. Not what video is it? Yelah. Okay. So just imagine, okay, okay, this is member, vertical member, top chord, this one bottom chord. Okay, imagine this. Okay, this is the web member that we design now. Okay. And this right member, when you look from this direction, okay, this is what type of the arrangement, or maybe, okay, maybe I can find some, okay, figure image. Tadi saya cari ada. Tadi saya buat revision sikit tadi ada. Tak jumpa pula. This one. Second moment of errors of inertia. Not this one. Double angle plus. Okay, maybe this is the best. Okay, see? Maybe this is the arrangement. Okay, nampak? See? L here in this direction. Ini, like this. This one. Okay. So it depends, It depends on your arrangement. Then you know, buckling out of plane about what exists. It could be Z, it could be Y. This one. See? So I'm assuming, yeah, okay. Okay. Who can tell me, okay, this is the arrangement, actually, like this. Okay. So, okay, so this is Z axis. This is Y axis. Okay. Buckling at Z axis. Who can tell me? In plane, out of plane. Which one? Ambil lagi pun. In plane or out of plane? Y axis, in plane or out of plane? Which one? Who can tell me? Based on this arrangement, okay, I take this one as the example. I take this one as the example. Okay, of course we have few more members here. Okay, who can tell me? Okay, I'm referring to this, to this double angle, Okay, Z in plane out or out of plane? In plane or out of plane? Siapa boleh bagi tahu? Who can tell me that? Nuralia? Dah panggil ke tadi? Nuralia? 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 In plane ke out of plane? Yang ni? Z ni? In plane or out of plane?
Saya.
In plane or out of plane? Or you can refer to this one. This is the Z. This is the Y.
Saya
Okay,
rasa
Z will be buckle. Z, nampak ni? Nampak? Okay, Z is out. Okay, I will tell you later. Nurhana. Nurhana, why buckling? Why buckling? Can you tell me for why buckling? In plane or out of plane? Nurhana.
Ya saya.
Tengok ni.
Oh,
Dia buckle kat mana? Atas dengan bawah kan? Z depan dengan belakang. Y ni yang buckling dekat Y ni in plane ke out of plane?
Dekat out. Mungkin.
Macam-macam jangan teka. Faham. Kena faham. Tengok gambar ni. Tak nak tengok ni tak apa. Tengok ni. Sini. Ni. Dia susun macam ni. Ini Z. Ini Y. Z ke sana, ke sini. Ke sana, ke sini. Y ke atas, ke bawah. Ke atas, ke bawah. Y. going downward, going upward direction. Z, I can say in and out. Can I say towards me? For this, from me? From this example, from this figure, Z is out of plane. Kan dia keluar daripada satah tu. Ni kan satah dia. Ni kan satah. Imagine lah, ni kan semua dia duduk dekat satu garis yang sama. Kalau dia pergi keluar, pergi sana, keluarlah. Kalau dia turun ke bawah, dia masih berada dalam satah yang sama. Kan ni. Macam ni. Ni member dia kan? Ni member kan? Kalau dia keluar ke sana, pergi ke sini, bakal dia terkeluar satah lah, terkeluar. Ini kan satah dia. Kalau dia pergi ke bawah ni, ni lah. Kita ni member dia. Ni, dia pergi ke bawah, kan duduk dalam satah. Kalau pergi keluar, dah terkeluar dari satah. Terkeluar. Ni kan, dia bakal kan. Ni kan, ni member. Saya buat dia terkeluar. Ni dia keluar. Ni kan satah. Ini satah. Nampak ni, dia terkeluar. Terkeluar. Kena imagine sikit. Saya tak boleh nak bantu yang ni sangat. Kecuali dengan pertolongan ni. Okay. So, from this example, this is the arrangement. From this in plane. The Y will be the out of plane buckling. Okay, that's it. I think I already solved this example. It's just that in this module I do not put the figure. Okay, so so this is the figure. Okay, just something that may help you to visualize. To help you to visualize. Okay, that's all. Okay, I have one last. Okay, no. Before that, we stop at NBZ. So, to solve NBZRD, you need to determine chi. Not chi, chi. Okay, you need to determine chi. So, in order to determine chi, you need to determine phi, you need to determine alpha. What else you need to determine? Lambda bar. Okay, for Z, of course, this one should be Z. Okay, you will not lose if you refer exactly this Euro code. See, to determine chi, you need to determine phi. Before you can determine the value of phi, you should determine lambda bar. Okay. NCR, once you know the NCRs, okay, you can know the value of lambda bar. Okay, the other unknown is alpha. Alpha is from table 6.1, but table 6.1 required the buckling curve. To determine the buckling curve, refer to table 6.2 first. Since we are using angle, so according to table 6.2, this is the this is the guide. Okay, angle. It said that here, buckling about any axis. Doesn't matter Y or Z, any axis. Okay. For Y and Z, buckling curve for S355, you need to refer to B. Means that buckling curve for Z, buckling curve for Y, buckling is from B. Okay, B. Buckling curve B. Buckling curve B. Doesn't matter for Y or Z. So the imperfection factor, alpha here, doesn't matter Y or Z. Alpha here is from buckling curve B. Okay, where the value of alpha z is equal to alpha y is 0.34, since it said any axis. Okay. Okay, what about this one? This one. Oh, it said that the value of reduction factor chi for the appropriate non-dimensional slenderness lambda bar may be obtained from figure 6.4. Okay. Okay. Can we use figure 6.4? Yes, we can use, because that is what included in the clause. Okay, how to use figure 6.4. Last time I teach you how to do it manually. Compute all the formula. Okay, but now from figure 6.4, this is actually can speed up your design process, because by using this figure, you can skip one procedure. Okay, I will tell you later. Okay, do we have lambda bar? Do we have lambda bar? Yeah, we should have lambda bar first. Okay, so for lambda bar, I just refer to this value. Lambda bar z 1000, dia betul. 1000. Lambda bar beribu-ribu ni. Lambda bar. Dia tak.
Punca kuasa.
Punca kuasa. Okey. Punca kuasa dia tak letak kat sini. Okey, think dekat modul saya ada kan. Modul saya dah letak ni saya. Okay, let's see what is the value of lambda bar here. Yang ni pun tak, ni salah. Okay, berapa?
1 point betul.
1408 square root. Square root 1408. 37. 37. Tak mungkin ni. Okay, kejap lambda bar. Lambda bar.
Doktor, bila kira dia punya jawapan patutnya 1.408. Maybe dia tinggal berpuluh apa?
Oh, 408
1.408 patutnya.
Bukan satu. Okey, 14.08. 14.08
1.408.
Oi. 1.408. Dia dah kira Lepas tu kalau
kira.
square root. Oh, dah square root dah 1.408. Okay, kita try Try. Let's say 1.408. Let's say lah slightly here Slightly here. Okay, we know that the buckling curve is buckling curve B. This is A node A. So this the third the third line is B, and then sorry menggeletar ni Okay, so chi should be 0.35, maybe 37, 38, maybe. Okay lah, 0.378. From the calculation, this is of course more exact method. Okay, by compute all the value into this equation. You compute the value. Okay, of course, this is the more accurate 0.374, but by using this figure, it just can speed up your design process. Okay, but maybe this is just the estimation. Estimate 0.37, 0.37. But from calculation, okay, more exact method, 0.378. Okay. Okay. So I hope that you know that you have other option. Okay. By performing all the formula, okay, by calculate all the value from this formula, or you can use figure 6.4. Okay, the other information here is said that for slenderness, the lambda bar that less than 0.2, or NED, the ratio of NED to NCRD less or equal to 0.04, the buckling effect may be ignored. Okay, what's that mean? The buckling effect may be ignored. Means that you fulfill either one because it said or mana-mana satu. So you can ignore buckling effect. Means that you do not have to compute the value of NBRD. Instead, you focus on cross section check only. Means that you need to calculate only NCRD. Means that the element that you try to design having more resistant in terms of buckling, or it is, maybe short element, stub element where buckling is not significant. Okay. Once you assess this one, means that you can know whether not to or have to perform NBRD, since NBRD is quite tedious, right? The process is quite lengthy. There's a lot of things that you need to compute and you need to refer. Okay, another example, let's check another exercise. Just to use figure 6.4. Exercise how to use figure 6.4. Okay, see, we need lambda bar, right? Lambda bar here is 1.085. Can I take 1.085? Can I take 1085? Boleh? Okay, let's see. 1085. Okay. 1.0. This one is 1.15. Okay, 1.085, maybe slightly here. Still B. Okay, and then okay, 0.58. 0.58. 0.544. Tak berapa, 0.44. Okay, tak berapa tepat. 1.085. Can I say 1.1 lah? 1.1. 1.1. This is 1.5. 1.1 should be 1.1. Susah juga maybe it's here. Should be here. 1. Bagi 2 lagi. 1 tolak 1.2. 0.2 divide by 2. Oh, 1.1 is here, in the middle kat sini. Should be here. So, see, pentingnya. Nampak ni kat sini. Okay, mine I got almost 0.55, but the exact, from the exact calculation, 0.544. See, it's quite close. Okay. Okay, next. Okay, next. Remember that I teach you on how to calculate A net based on staggered whole. Last time we use quite simple example. Okay, now, okay, let's say we determine the A net from this unequal angle. Okay, first what you need to do, first you need to determine the possible failure line. Okay, the possible failure line. In this case, as you can see, there are 3 possible failure line, okay, that you can come out with. Okay, Okay, first it can fail perpendicular to the axis of member. Let's say this is the NED. Okay, this is the first. Okay, just cross to one boat hole. The second failure line, crossing two boat hole. Compared to this one is much more critical. Okay. It also can fail diagonally or based on zigzag line. Can I use diagonal line? Yes, I can. 1, 2. 1, 2, 3 ke sini. 1, 2, 3. This is let's mulalah. Okay, first. Okay, second. I'm following this solution. Second. Can I use the other color? Okay, this is the second failure line. Okay, the third failure line. Oh, I'm following the solution. Third failure line, zigzag. To me, I have fourth failure line, crossing both hole, both of the boat hole here. This is number 4. Okay, based on this failure line, you will assess. Okay, failure line 1. Okay, what is the general equation? A net is equal to gross area minus any area due to hole. The first failure line crossing just one boat hole means that from the cross section, this is what you will see, right? AG is gross area. In this example, we are using unequal angle. Unequal angle where the gross area of this unequal angle is 50.5 centimeters squared. Okay, if you do not know, if there's no data given, but you only know this and you only know the size, okay, the size, what you need to do, okay, refer to angle, unequal angle. Okay, equal angle. Okay. No, sorry, not that. This one. Equal angle, back to back, equal angle. Okay, unequal angle. Okay, what is the size? The size 200 times 150 times 50. 200, 150, 200, 150 times 50. So this is the size. Okay, the area is 50.5. See, this is how you get the parameter, the value of that parameter, 50.5. So 50 minus any area due to hole. Hole. Okay, what is the other information that we can get from this question? Okay, D naught is 15, means that the radius, the radius of the bolt hole is 15. 15. D naught, D naught. Okay, D naught is equal to D, diameter of hole, plus clearance. But the D naught already given for this example. So what is the area here? 15 times the thickness. What is the thickness here? We are using 200 times 150 times 15. So thickness is 15. So 15 times 15. Just one bolt hole. Okay? From the first failure line. Then you can get your A net. Then failure line number 2. Failure line number 2, A net is equal to AG 50.5 centimeter squared. This one is in millimeter. So you need to convert first before you solve this problem. You solve this equation. So for failure line number 2 is diagonal. It's diagonal. For diagonal, I need to use equation. Apa equation dia? What's the equation? Second. SDAG. Okay. Okay. What are the, okay. T A net, okay, still A net is equal to AG. A net is still equal to AG minus any area due to holes. This is just a layman understanding. Okay, but the area to be deducted is from A or B. A is this one, B, okay. The failure number 2 is B, because zigzag line or diagonal. For diagonal or zigzag, it said for diagonal, this one A is perpendicular, line that perpendicular to member exists. The B, okay, measure on any diagonal or zigzag line. So I need to use this formula for area to be deducted for this value, okay, where the T area to the hole is equal to, I'm referring to the B case, T and D naught minus summation S power 2 for P. Okay. T, thickness, is 15. N is the number of hole. Failure line number 2, crossing 2 holes. So 2. D naught is given 15 minus S. What is S? S is staggered pitch of the 2 consecutive hole. Means that this one, S. Oh, sorry, S here. P is here. S. Okay, S. So S, we only have one S. This is S1. based on this board, okay? This is the P. I put P1. P1, okay? So summation only involve one S and one P because only it's crossing only two holes, okay? So S is 45, power of 2 divided for P. P is apa? 60. Can someone compute for me? Okay, can someone compute for me? Boleh? Siapa boleh tolong tadi? Cepat, tak sempat ni nak buat lagi yang lain. Hello. Kejap. Kejap. Wait. What is S? Kita check balik. Let me check. S. Ni gambar S lah. P is spacing. Perpendicular. Okay. P is spacing perpendicular of member S. This is member S. So this is the P. This is the S. Sorry. So S is 60. 60 power of 2. This one 45. Okay. Ada yang jawab ke? 150. Oh, okay. 150? 150. Okay? Okay, so A net is 80 minus 150 mm squared. I'm not sure whether this is right or wrong, but the answer should be, this is the answer, should be 49 mm squared. Okay, for the third failure line, okay, third failure line macam ni. Okay, we know that the area to be deduct, we understood that as a whole should be calculated from T and D naught minus summation S power of 2 divided for P, where T is the thickness, 15, and is the number of the bolts. T naught is 3 minus. Okay, this is the S1. From here to here. From here to here is another S. S2. From here to here we have P. I put it as P1. From this board to this board, this is the P2. See the summation. The summation. The jumlah. So S1 should be 60 power of 2 divided by 4 times P1, okay, P1 45, okay, plus 60 power of 2, sama 60, okay, 60 is 40, okay, 4 times S2. Sorry, no, this is P2, so, betul lah, 40, okay. See, 45, 41, okay. A hose. Okay, then calculate for me. Then A net, stick to this general formula. AG is 50.5 centimeter squared minus whatever value that you get from this calculation. Minus A. Okay. And then you have another failure line. Failure line number 4. Okay. Okay. So, okay, that's all for today. Tomorrow we try to do another topic, not subtopic, beam element. But before that, as usual, I need you to answer, answer question from author that I already put in author. This is for attendance for today. Okay. Okay, I'm giving you. You need to download the figure and then you upload it again. Okay, in order to answer my question. Can I give you like a, until 4? Until 4, Okay. Okay, now you can access. Okay, you can access just a simple question. Okay, not involving calculation, but yep, as an exercise, I can give you the okay, later on, I can give you the question that related to the calculation, but for quiz, it's just that you need to sketch the failure line, the possible failure line. Okay. Okay, while you try to answer, I hope that you can understand this is a plan. This is plan view. What you see here is actually maybe I or H section. This dotted line represent the web. Okay, macam ni. Okay. Section. Okay. So, you ada apa? Dia ada ni. So, ada 3. Ada 4. Okay. For both connection. Okay. Okay, that's all. Okay, try to answer. I will consider your answer as your attendance for today. You need to download and then you upload it, okay? Okay, siapa dah sudah, thank you so much. Don't forget you have 6 minutes more. Saya harap awak boleh faham lecture hari ni. Dan please lah study sebab dah habis 2 topik tau. First, introduction. Second, introduction to include what you already learned, include section classification, include That's it. Section classification. Section classification lah. Okay. And explanation about the load combination. Yeah. Just refresh. Okay. Then we finish with truss design. For truss design, we have 3 type of design. First, member with compression plus bending at top chord. Second, tension member. Third, compression member, pure compression. Okay, so yep. Dah habis.
Saya punya wetting 2 dah okey. Saya punya BFK.
Okay, it's okay.
Sikit je sebab tu. Lepas tu saya dah buat quiz guna author, guna assessment. Tapi bila dia dah sebab dia ABC kan, dia dah ada markah. Tapi macam mana nak dapatkan senarai markah tu semua?
Excel, convert ke Excel. Nanti I try.
Saya cuba tak boleh.
Nanti I try.
Dia kata tak ada kena add mark lah.
Betul.
Memang ada kolom mark tu kena letak berapa markah.
Ada saya dah letak markah.
Dah letak?
Cuba dulu.
Okay, nanti I try. Okay.
Doktor,
Ya.
boleh ke saya hantar dekat WhatsApp sebab saya
Apa?
punya macam iPad tak ada bateri tiba-tiba. Saya tak
Alah,
perasan.
pernah kita.
Saya tak boleh nak sketch.
Siapa yang ada problem, kena cakap dalam waktu masih ni. Kalau dah lepas, saya anggap you tak ada. Lepas tu kawan you bagi tahu. Lepas tu tiba-tiba you nak buat. Saya tak nak. Tak adil untuk orang yang datang. Okay, so siapa nama? Nama.
Liana Natasha, doktor.
Okay, hantar sekarang kat saya.
Okey. Tapi saya tengah charge saya punya pensel sekejap. Saya tak boleh nak sketch ni. Lepas saya dah sketch, saya hantar terus
Kalau
dekat
3 minit ni.
okey, jap. Saya tengah charge ni.
Kalau tak awak lukis dekat kertas, lepas tu snap ke? Bukan susah
boleh,
pun kan? Nak tengok gambar dia? Sekejap.
Okey.
Siapa yang
Tak
tak
apa.
boleh tadi?
Gambar dah sempat download, doktor. Cuma saya tak boleh nak sketch dekat
I see.
gambar
Pen itu. Okay.
alright, doktor. Thank you, doktor.
Okay, thanks Atira. Naiman, okay boleh keluar. Siapa yang dah sudah? Okay, ramai dah sudah. Okay, thanks. Boleh keluar lah, ya. Jumpa esok. Tolong belajar, tolong sangat sebab bila saya tanya ramai tak jawab. Awak akan faham lah kalau awak mengajar, lepas tu kita sedih lah sebenarnya. Tak adalah kita.
Doktor,
Ya.
untuk full slide tu kan boleh share tak? Sebab yang doktor bagi tu sampai 60 lebih lah. Dia punya pages.
Memang? Okay, nanti
nanti.
saya ni sebab kita dah habis topik pun, saya bagi.
Okay, terima kasih doktor.
Ya, sama.
Thank you doktor.
Sama.
Doktor, saya tengah upload.
Upload. Saya tak set pun dia tutup. Kenapa? Alah. Saya takut lah hantar WhatsApp. Sebab dia tak record kan. Hantar cepat. Siapa yang tak ni? Okay. Okay. Try dulu hantar.
Lecture, sorry. It's not allowed to say. I don't know why.
Not allowed.
Yeah. When I
Why
check
it
the
is
save
not
answer,
allowed?
he said the error.
It's the error.
Yeah.
You're here, Said. Ah. I have your answer. I have your answer. I have your answer.
Okay,
See?
thank you. Okay.
Ah, okay. Okay, I'm giving like 2 more minutes. After that, at 4:04, at 4:04, I'm not allowed any submission. Okay, I'm not allowed any submission. Okay, see you. Bye.
Oh, Doktor, saya dah upload.
Yeah. Yeah, Liana.
Okay, thank you, Doktor.
Okay, bye.
Thank you, Doktor.
Okay, bye.
Thank you, Doktor.
Okay, bye.
Thank you, Doktor.
Sama.